All right, so let me very briefly go over some functions that are going to help you just very quickly determine if it's continuous, discontinuous, or somewhere in between. So let me go over some functions that are continuous everywhere. Let's start off with a simple one, like polynomials. Any polynomial, no matter what it is going to be continuous anywhere. Whether it's got a x squared or an x, or maybe it's got an x to the fourth, doesn't matter. Even if it's just a plain old number by itself, those functions are continuous everywhere. Let me go over some others. An exponential function is going to be continuous everywhere. All right? Now, exponential functions, remember, have an x in the exponent. Again, let me repeat. They are continuous everywhere. Now, next part. Sine and cosine are functions that are continuous everywhere. So no matter what's plugged into them, or if it's a sine squared, doesn't matter. If it's a sine or a cosine, it's continuous everywhere. Now, last one I'm going to talk about are odd radicals. That means something like the cube root of x. That is continuous everywhere. Now, you're asking me, what about the even radicals? We're going to get to that in a second. So, all right. Those are functions that are continuous everywhere. Doesn't matter what function you have. Doesn't matter what x is, what y is, doesn't matter. These functions are continuous everywhere. Let me talk about some functions that are not continuous everywhere, but are continuous on their domain. For instance, let's talk about rational functions, because those are the ones we see a lot, okay? Rational functions are things like, and I'm just going to pick one off the top of my head, x minus 4 over x plus 1. Now, that is continuous most places. So you're going to ask me, Mr. Harrell, where isn't it continuous? Well, it's wherever that denominator equals 0. So in this case, it's not continuous at -1. It's discontinuous at x equals -1. So that's what I'm getting at here. Again, all you got to do, take the denominator, set it equal to 0, solve. That tells you where it's discontinuous. Let me look at another one. We've got logarithms. Logarithms are another example of functions that are not continuous everywhere. Here's the reason why. You cannot take the logarithm of -1. You can't do it. It's not going to work. You also cannot take the logarithm of 0. Can't do it. It's not going to work. Now, the things that you can do are positive numbers. So, even 0.5, you can take the log of 0.5. And it doesn't matter what the base is, whether it's base 10, base e, base 57, doesn't matter. You can't plug in negative numbers, you can't plug in 0. So, here's the trick. Say x is greater than 0, and you've got it set. Anytime x is greater than 0, or whatever you're taking the logarithm of greater than 0, that's going to be where it's continuous. Let me keep going now. So we did rational, we did logarithms. I'm going to talk about tangent and cotangent. If you've got tangent and cotangent, they are not continuous everywhere. They have certain discontinuities. If you remember from your pre-calculus or advanced algebra trig days, you might remember that these two things have a lot, and I mean a lot, of vertical asymptotes. Now, we're going to talk more about that in a little bit, but just remember, they're not continuous everywhere. They're continuous on their domains. They're going to have asymptotes. Another one, secant and cosecant, also has lots of vertical asymptotes, all right? So, be careful with those. Tangent, cotangent, secant, cosecant. Again, any of those, if you got them, they're going to be discontinuous at certain places. They're not going to be continuous everywhere. One last one that I want to talk about, because I said I was going to come back to it, is even radicals. So, things that are square roots of x, or even fourth roots of x. If it's an even number up there in the index, it's going to be discontinuous at certain places. It's continuous where this thing under the radical is greater than or equal to 0. So those are some helpful hints to help you make your way through this stuff with relative ease. Again, these are just quick ones that you should be able to know right off the top of your head. I'll make sure I mention another one. If you have a step function, be very, very, very careful. They are neither of these categories. They have lots of discontinuities, even though they are in their domain. So just be careful of those. Like I said, these are ones that you should know right off the top of your head. Hopefully that helps.